Alright, hello. The homework kicked my butt. But I think now that I've kind of figured it out, we should really do please know that I really have no idea what I was doing on number 3. So I mean, like, I'll explain it, but when I get to it, if you just want to wait until after I ask Coke, that's totally fine. I anyway, let's go ahead and start at number 1. Number 1 is nice, kind of, because we're just doing basically what we did last time. So they're gonna give you a table, and then they're gonna give you another table with nothing in it, and they're like, hey, find all this stuff. So remember that to find the sum of squares between treatments, actually it's easier to find the sum of squares total first, which remember is the sum of x squared minus g squared over n, where g is the sum of x, which they give all that to you. So that's pretty simple to find. And then they want you to find sum of squares within, which is just all of the sum of squares of the conditions added together, which they give you all 3 of them. So just add those together, and that is your sum of squares within. And then your between is just your sum of squares total, or your sum of squares within subtracted from your sum of squares total. So that is that. And then to find your sum of squares between, you're going to take k minus 1. And remember that k is the number of manipulations or levels or whatever you want to call it. So you have A, B, C, k is 3. So 3 minus 1 is 2. So that would be your degrees of freedom for your between treatments. Your within treatment degrees of freedom is capital N minus k. And they give you capital N. Just know that capital N is all of the n's added together, like the little n's, and n being how many people participated in those studies. So when you do that, you will find your degrees of freedom, and then to find degrees of freedom total, you can just either add between and within together, or you can subtract 1 from capital N, and that is your degrees of freedom total. Now, to find your MS, basically you divide your sum of squares between by your degrees of freedom between. That's how you do it. And then the same for within, you divide your within SS by your degrees of freedom, and your between should be bigger than your within. And then to find your F, you divide your MS between by your MS within, and that's your F. Okay, to find the F critical, you go to the F distribution table. I'm pretty sure, I haven't done this in a while, but I'm pretty sure that's where you go. And then on the left, you do your degrees of freedom on the bottom. So your degrees of freedom within, and then on the top, you do your degrees of freedom between, and then you just like go down and you're like, oh, that's my critical point. And remember that they want alpha to equal 0.01, so that's the bold number on that table. And then if your F number is larger than your F critical number, you're going to reject it, and if not, you're going to fail to reject it. And remember, if you fail to reject the null hypothesis, there is no significant difference. If you reject the null hypothesis, there is a significant difference. That is how that works. Alright, and so then you wish you were done, but you're not, because then they want to know between subjects and error. What's nice about this table is you've already figured out between subjects, sum of squares, and between treatments and within treatments. So you can just copy all of that over. You've even found your MS for between. Your F is different, so don't copy that over. Your total's the same. So anyway, basically, you're just going to be looking for between subject and error now. To find the between subject sum of squares, you are going to do the sum of p squared over k minus g squared over n. P equals each, it equals the the added rows. So like your first P would be 6 plus 3 plus 5, so that'd be 14. The way that this works is when they want you to assume that it's a repeated measures test design now. So instead of having 3 different groups, you're just having 3 different treatments to one person. So P is just the combination of all of those treatments. So you should have 5 different P's, all with, you just add them together this way, or this way. I don't know what it looks like in the camera, but those are your P's. And so you're going to take each P, square it, and divide it by little n. No, divide it by k. So divided by k, which you already know is 3. So you're going to have 5 different P's, each of them squared over k. And then you're going to subtract g squared over capital N, which they gave you. And that will equal your sum of squares for your between subjects. And then you need to find your sum of squares of error, which I don't think there's actually a formula for it. I know there is. It's just he never gave it to us. It's just your within. You subtract your between from your within. Your between subjects. So the one you just found, subtract that from your within number, so your second SS, and that'll equal your error. And you should, if you do that, your error and your between subjects should add up to your within treatment. If they don't, that's bad. You did something weird. Anyway, to find the degrees of freedom for between subjects, you would do n minus 1, so little n, so that would be 5, n would equal 5, I think, yeah, because there's 5 people total, because there's 3 different treatments happening to 5 people, so 5 would be your n, and so it's 5 minus 1, which is 4. To find your degrees of freedom for error, it's basically your degrees of freedom for within treatment minus your degrees of freedom for between subjects. And that is your error. And then to calculate the MS for error, you just do your SS error divided by your degrees of freedom error, and that equals your MS. And to find the F value, you take your MS between treatment divided by your MS error, and that is your F. And you do the same thing to find the critical F value. So you go back to the table and you say that the error you use, for the error on the bottom, you're going to use the degrees of freedom error. And for the degrees of freedom on the top, you're going to use your between treatments, because they're both between treatments. So then remember, if your F is bigger, you reject. And that is number 1. Okay, so number 2 was a pain in the butt. This whole thing was a pain. Anyway, okay. So, very, very first thing you do is you have to read this one a little carefully to find your variables. You need to find k, which, when they say that it's a repeated measure, ANOVA, comparing 4 treatment conditions, that means that your k is 4, because there's 4 different treatment conditions. So that's what k is, and then they give you the sample of n equals 10, and by giving you little n equals 10, you should know that capital N is going to be 40, because it's the number of treatments times the number of people, if that makes sense. So those are your variables, and they want you, they give you some stuff filled out. Whenever you do this, it's just easier to find degrees of freedom because you don't really need anything. What you need they already gave you. So remember, to find degrees of freedom between, it's k minus 1. Degrees of freedom within is n minus k. Degrees of freedom between subjects is little n minus 1. Oh, right. Do know that degrees of freedom within is capital N minus k. And degrees of freedom between subjects is little n minus 1. And degrees of freedom of air is just your degrees of freedom within minus your degrees of freedom between subjects. So that's that. And your total is just capital N minus 1. Alright, so now that you have all of your degrees of freedom, you can figure out your sum of squares between treatments because your ms between equals your sum of squares divided by degrees of freedom between. So that means that if you have, just pretend like SS is x, so basically you have x over your degrees of freedom equals your ms. So to solve for x, you would multiply your degrees of freedom by your ms, and that will equal your sum of squares. So that's how you figure that one out. You can also figure out, oh no, you can't. So then once you have your between, also what's really nice is because air and between subjects add up to within, you can just subtract 108 from 158 to find your between subjects sum of squares. And so once you have found your between treatments and your within treatments, you add them together and that's your total. That's pretty nice. And to find your ms error, you take your SS error divided by your degrees of freedom error, and that equals your ms error. And then to find f, you take 20 divided by your ms error, and that is f. And they don't even ask you if you reject the hypothesis or not. Alright, so this is number 3. I'll tell you what I did, but I honestly have no idea if it's right. I struggled so hard. The main reason it was really hard is because the relationship between t and f is f equals t squared, and I couldn't get my t to equal, to be the square root of f. So, whatever. The equation you'll use to find your t value is t equals the mean distance over the square root of variance over n. So the square root of the entire and variance over n. To find variance, you have to find sum of squares first. So sum of squares is going to equal the sum of d squared minus the sum of d squared over n, little n. So d is the difference, and they give you the difference, so don't worry too much about it. When you do the sum of d squared, that means that you have to square each of the differences and then add them together. And then the sum of d squared is you add them all together and then you square them. So, and then your n is just, how many people, so how many subjects, and they tell you exactly how many subjects there are. So, yeah, you'll find this answer, and that's your sum of squares. So then to find variance equals the square root of sum of squares over degrees of freedom. So once you find your sum of squares, plug it into that equation, and that is your variance. So that's great. And then to find t, you need to find your mean difference, or the difference of means, I think is what it's actually called, MD. So you basically add up your differences, and you divide by n, and that is your mean difference. So, or difference of means. And so then you put that on the top in the numerator, and then you divide that by the square root of variance over n. And that should equal your t. I got 8.324. I don't know if that's right. That's what I got. I did this so many times. And so, according to that, you should get like a 64 point, or 64-ish F, which I didn't. And I'll keep going and you can figure that out. To get your T critical point, you have to go back to that stupid, TUMP table, the T distribution table, and I think it's a two-tailed test.